We're going to be making a foldable today about simplifying roots with variables. So take the cutout that you were given in class. All we need to do is make one cut right in the middle between the 98 and the x to the third power. And what we're going to do with these is we're actually going to fold them down. And we're going to use that title section to glue. So you can go ahead and glue now. That's what I'm going to do. So just right behind that simplifying square roots with variables, that's where we're going to glue. And then we're just going to go ahead and paste it. So now our flaps come down, but we've got that title that stays there. Now, in your notebook, we're going to talk about doing the square root of this expression. So we're actually going to draw a square root around our expression. Now, 98 is just a number. In mathematics, we call this a constant. It will constantly be 98. There's no variation in that number. On the other hand, x to the third, that x is our variable. Because there is variation, it can change depending on what we substitute in for x. So those two parts are important. So with our constant, this is what we've been doing in class. This is when we look for perfect square factors. So we're looking for those perfect square factors. So in 98, I'm just going to give you a hint and tell you that 49 is a factor. It is also a perfect square. And 2 is the other factor. Now this is what we've been doing for this whole past week. I know that that is now 49 times 2. Simplified is 7 square root of 2. So that's just the 98 part, boils down to 7 square root of 2. Now if I look at the variable side, this is the new part. So when we're looking at variables, we can think about it as a perfect square roots, just like we do with our constants. Or we can look at the exponent. When we're looking at these exponents, we're looking to divide by 2. A square root is just a factor of 2, so divide by 2, and then the remainder, there's an n there, stays in the radical. So like I was saying, I can think of x to the third power as that perfect square tree, just like we did with 98. Break it down into x squared times x. And that's fine, but it gets more difficult with higher powers. So what I'm saying is look at that exponent. So take the 3. We're looking to divide by 2. Well, 2 goes into 3 one time, and there's a 1 remainder. So that means that I can pull 1x out of the square root, and 1x is left inside the square root. So 3 were there total, 1 came out, and 1 stayed in. Now I've got my simplified versions of my constant and my variable. I can combine them together to make my final answer. So when I do that, total answer would be 7, that's on the outside, and x. And then I look what's under the radical, I have a 2 and an x. That's my final solution. Very good. So I want you to try a couple in your notes. I'm going to give you 3 problems. I want you to try those as your homework and then bring them in tomorrow to check. So we're going to start with the square root of 72 x to the fourth. So think about it. Is there going to be a remainder? If there's no remainder, what does that mean? Then let's try square root of 45, x to the fifth. And your last problem, this one's a little bit more challenging. We're going to do 8 square root of 27 x to the third. So think about all of those radical rules that we've been working on and then what we've just learned as our variables.